Good morning. Good morning, good afternoon, good evening. It's another Wednesday. It's another episode of the Weekly Tech Forum sponsored by Love My Tool. And today it's my pleasure to introduce some very good friends. Two of them are actually from one of our sponsors, NetFort. Good evening, John.
Good evening, Denny. How are you?
I'm good. So John is the CEO and the co-founder of NetFort, and also good evening, Darragh.
Good evening, Denny. Good
And
morning.
good morning. Yes, good morning for me. Yeah, that's true. But anyway, and good afternoon, Tim.
Good morning out there, and good evening out there.
Yeah. So today, this is actually the second time that we're doing this in this particular format. It's a sub format of the LMTV where we're really trying to extend the Shockfest experience. And so the presentation today is supposedly vendor neutral, although both Tim and I come from the vendor background. We had started our own companies, sell products, and so forth. So we understand firsthand how that is actually impossible to separate our enthusiasm for the technology from the enthusiasm for our own product. And we don't want you to do that. That's not the point here. But the point is that what we like to do is to present some knowledge. Something that back in the days when I was in academia, something that we call something of archival value. So we after there was a live demo a couple weeks ago, we decided that there's something that is really worth talking about, which is something called metadata. And so with that, I'm going to turn the podium over to Darragh and let him do his presentation. Go ahead, Darragh.
Thank you, Denny. Just start my screen share here. Okay, I assume you can see my screen now. So this is my my agenda. It's not a PowerPoint presentation by any means, but I just have 2 or 3 slides here. I'm going to do a deep dive using Wireshark into 2 popular protocols, HTTP and SMB. And I'm going to look at locating important metadata in network packet dumps. And finally then, because it can be hard work trawling through packet captures or packet dumps looking for metadata, I just want to show you ways of automating the process with software tools. So why do we even need to look at metadata? Well, the reason is, because of user issues is the main one. People build networks because they need people to come in and use the networks to do stuff, whether it's legal firm moving some documents around, software development company moving software around. But what happens is we have user issues, and look back on our own database as to what sort of problems user cause. And we have things out there, these are my names on them here. We've got Download Dave, who's just constantly downloading stuff. We got Web Surfer Wendy, we got Malware Michael, Bandwidth Mandy, File Delete Frank. Some of these users do things accidentally. Some do it because they're bored and they want to go online, they want to do stuff. At the end of the day, they cause problems, and those problems impact on other users. So the IT people need to weed these types of individuals out quickly. And there's lots of tools out there, log tools, there's agents you can install, there's loads of things you can do to try and figure out who or what is causing the issues on your network. So one of the ways you could weed these people out is by looking at metadata. Now, metadata these are some examples. So for example, if you've got email, metadata could be something like who is the sender, who is the receiver, what's the subject line. It's not all of the email, it's not the entire content of the email, but it's key information that's enough to understand what the email was. Or if it's a HTTP or web browsing, you may just need to know the URL, the browser type, the URI, refer. So the metadata is like a subset of the entire conversation or the entire transaction, and it's enough that allows you to go back to the user and say, you deleted a file at this time. That caused a problem. Please don't do it again. Or you downloaded 10 gigabytes of data from YouTube. Well, that's caused us a big issue here. People, they were complaining the internet was slow. So this is what metadata is. It depends on the application, different types of metadata. So, give an example. Got my friend Wireshark here. So, Wireshark is captured for about 5 seconds, 5 or 10 seconds. I captured a bunch of data here, which at the same time I copied and I actually deleted a file off the network. And I've got here 5,000 packets of data. So I can start to trawl through it, and I can find SMB protocol in here. And in fact, I can start to see metadata. Now, this can be hard to spot here, but here I can see something called /clinic, email, patient records, x-rays, clips. So there's definitely something going on here. We definitely have people accessing some folder here, some templates. We can see an IP address. We got maybe a server IP address here. And this is metadata. In between the metadata, we have data being exchanged. And then here we have some more metadata, patient contact details.mdb. So we've got a database in operation here. Data being exchanged in between, more metadata here. I see some names being mentioned, and so on. And this goes on and on and on. So what I've got is data and metadata mixed in here in my packet capture. So if I want to find out now, well, who deleted the file? Well, what I could do is keep scrolling through these packet captures. And it is, you can do this if you want. Keep scrolling through, looking for the name of the file. I could go in here and use the find option, find packet. I can actually right-click as well, and I could actually follow the TCP stream, which kind of filters it a bit better. So I'm looking in here, is there any indication of somebody deleting a file? And believe it or not, it's here somewhere. I just need to keep looking. The name of the file, the action, what happened, the source and the destination, it's all here. I just need to be patient. I just need to be able to find it. So what this is, it goes to show you the power of the information that can be captured from network packets. I actually just did this by just running Wireshark and using promiscuous mode to just capture local data. But I could use a span port. I could use a tap. I could use many devices out there that allows me to get packet data. The problem is, of course, that for me to store this file and to go through this file, it's going to take me a lot of time. It's going to take a lot of disk space if I'm to store this an hour's worth of data, especially if I've got hundreds of users on the network. Let's have a look at an internet browsing. Take a look at some metadata from internet browsing. So I'm going to simply go to my browser here, pick some, let's go for Strava, doesn't matter, some random site. Here we got the Strava website of people out and about doing their cycling and running. And if we go back to our Wireshark now, just stop that. I can start to see some, in fact, this is some metadata in here buried. We can see /schema.org and some metadata in here, small amounts. So each packet capture will have the metadata in here. If it's regular browsing, and if this is HTTP1, if we do file activity, if we send email, we've got metadata available in here. And some companies, in fact, I was talking to one of the largest training organizations in the world, who they needed to basically store who was doing what on the internet when they ran training courses so they could troubleshoot problems afterwards. And before they even found the tool, when courses were being scheduled, they were storing the packet captures of each course and keeping them in an archive. They didn't have a tool, but they knew that someday or somehow they would find the tool to process the packet capture files, because they knew in those packet capture files the crucial metadata was there, which would show what site somebody accessed, what file somebody uploaded or downloaded. So they knew the information was in their packets. They just didn't have a tool that could interpret those packets or pull the information out quickly. So some people do know the power of capturing data from using sniffers. Some people understand the fact that there's metadata in there that's really useful, but it's amazing, not too many people know how to efficiently get the metadata out of the packets. I'm using Wireshark here, and it is difficult. It is difficult to apply filters and pull the metadata out. The other, and speaking to John earlier on, the other piece of data that's missing in here, because if I go back to my little presentation, managers, especially upper management, they don't understand IP addresses or MAC addresses. They understand Dave, Wendy, Michael. They understand names. They understand file names. They understand website names. But give them IP addresses and they start to glaze over. They don't, okay, I know what an IP address is, but what does this particular IP address, is this of some significance? So if I go back to Wireshark here, another problem we have is that each packet has got its source destination IP address, but it's not in a management-friendly, I don't see a username. Now, you could search all you want in here, but you won't find usernames in this, because normally what happens on Active Directory I'm most familiar with, the user logon happens once when the user comes onto the network, and that transaction, it can be seen as metadata as well, that's logged that once, and from there on in, it's an IP address that's used to access resources, and Active Directory takes care of making sure that this user has the access or the permissions to do that. So to get this management-friendly view, or if you do it yourself, and this is possible, you need to stitch together two pieces of data. You need to stitch together the information here I'm getting from Wireshark. We've got the source, we've got the destination, and we've got the actual action here, in this case a post and a HTTP request. And now what we need to do is go to our Active Directory logs. I don't actually have AD here at the moment, but anybody familiar with Active Directory will know what I'm talking about, is to do a search for this IP address to see, do we have a user associated with that? And if you find it, that's another piece of metadata. That's a username who's assigned to this IP address at this time. And now we've got something that everybody can understand. We've got a user, we've got a time, we've got a website, we've got a time, and even an action. And that can be then presented to the user, to a manager, or whoever that is. So metadata is not just present in packets, but there is also other metadata spread all over your network. And I think one of the most useful pieces of metadata out there is the user logon events that are stored on your domain controllers. If you don't have that enabled, I'd recommend, it doesn't matter what network tool you use, it doesn't matter, even if you don't use them right now, be sure you enable auditing on your domain controllers. Now, unless you've got some sort of a law or something in your jurisdiction that prevents you from capturing usernames, if you don't, it's a really useful piece of metadata to have, and it allows you to map your network activity to your user activity. So I could do more examples here. If I was to send an email using SMTP, I could get the metadata from that. Just a point to make here, it's actually, we talked about earlier on, and talk about packet capture and where packet capture is going, capturing metadata, and even I'm reading in the next update to Android, they're going to enable encryption by default, and the feds in America are getting very, very nervous about this. They don't like to see this happening, because everything coming in and out of an Android is going to be encrypted. So where does that leave metadata? But certainly it's going to mask, well, it's not so much mask, it's going to be impossible to extract the metadata from packets. It means that you won't be completely blind as to what is happening, but certainly some of the more useful metadata will not be able to be extracted from packets. But again, it's important that you could still run a packet capture of encrypted data. You could still see the source destination, the type of protocol in use. You could still see the data being exchanged, but there may be certain types of metadata that you would have got previously that you no longer see because the transaction is now encrypted. But again, it's important because some people think that once data is encrypted, there's nothing you can do. You can still capture that data. You can still do your analysis. There's some clever things you can do to recognize the applications that are being used, but some metadata will be hidden away from view. So that's a deep dive into probably the file share one was the more interesting there. We could really could see file names and folder names that we could recognize, and we could scroll through there to get some to find out maybe who deleted the file or who did something wrong on the network. So if you want to automate this, there are tools out there. Now there are, with different ends of the spectrum here. We've got Wireshark, which is free, but it has its limitations. It's fantastic for running locally and doing some troubleshooting, but if you want to scale up and capture data for hundreds of clients, you're going to run into problems very, very quickly. You could go out and look at the packet recorders, which store every packet in big databases. They are expensive, and you're going to need massive storage requirements. So I got my Wireshark at the end. It's cheap over here on the left. Information can be complex, which I showed you there. And over on the right-hand side here, we got some packet recorders. They are more expensive. Now there are products that fit in the middle here. Just quickly talk about our own, but there are other products that you can find that fit in here, which they don't capture all of the data. They do more than Wireshark. They put some meaning on the data that when you look at it, at least it's meaningful. But just to give you an example, I'm just going to log on to one here and show you what it would look like where you do some processing of the packets so that you clear away you mask all of the bits and the bytes and all that heavy lifting that you need to do in Wireshark and be able to access that data quickly. So if I go back to, we had one of our characters who was, file delete Frank. We want to figure out who deleted the file. So I'm going to go to search here. I'm going to go to file activity and some finance file. And just press go on that. Okay, so let's get the usernames. So what have we got? I've got here, you've got an IP address. I could see that in Wireshark. Remember, we could see that here in Wireshark, and that's exactly, it's the same data, that this IP address here, that source, that was extracted from the same packet. Well, not necessarily the same packet, two different ones, but the same idea was taken from the header of the packet. We've got the path here, we've got the name of the file and the document in the folder. And again, we could see that in Wireshark, but here it is, it's much easier to view it here on this screen. We've got the number of actions and the amount of data. This has summarized all of the other stuff that we saw in Wireshark. So the other segments and the other bits of data that was sent and received, that's been summarized here to give us a total amount of data. And then we can drill down on this, and we can crucially then see the action here that this actually was deleted, in this case by some chap called Robert Schmidt. Again, this data is out there in your packets, but we'll just bring it together here so that on one screen we've got the user, we've got the source destination and the file name, the fact it was deleted. Every single piece of data here, okay, bar the username which came from an Active Directory log, but every single piece of data here was extracted from packets, it's metadata, and it's enough now that I can pick up that phone and call this user and say, look, you deleted a file at 1617. have you got a local copy of it? Could you put it back up on the network? People are asking that was a shared file. It's gone missing. If you don't have it, I need to go to tape. But please, if you have a copy, put it back. So we didn't need to be looking at timings. We don't need to be looking at logs and servers. We track the user. We need to figure out. We can call them and try and sort out the problem there and then. So this is the power of metadata. It gives you the data to address a lot of the problems or the usual suspects who keep coming up on networks. It doesn't matter what size network you have. It could be just 100 users. It could be 10,000 users. But some of these characters will arrive in, malware Michael. He may be completely innocent, but he just happens to have some malware on his laptop. Comes into your network, starts to spread around. Bandwidth Mandy brings in her iOS device. Apple updated there 10 days ago or whenever it was, an 800 megabyte download. Suddenly, your internet pipe is choked. Web surfer Wendy was watching the Ryder Cup last weekend. We've actually seen it ourselves. Choking again, bandwidth on their internet pipes. So these suspects, we see them on every network. Doesn't matter what part of the world it is. They come in, and IT managers, they need to weed them out quickly. And we think one of the easiest way to do this is capture metadata so that you're not having to trawl through packets, but simply looking at the actions of the users to identify them and then deal with it, whether it's to just tell them not to, or maybe you need to block a website, maybe you need to take their laptop and clean it out. So that's an example of where the power of metadata can be used for day-to-day activities. I know, John, do you have a couple of examples?
Yeah, thanks very much, Darragh. It's interesting. I guess, as you said, we think metadata can be very useful for anything that's user-related. So when somebody's troubleshooting something and they're talking, is it the network, is it the user, or is it the application? Obviously, with Wireshark and tools like Wireshark, with the timings and stuff, it can really help when trying to narrow down to the application. If it's user related, if it's somebody downloading a large file over a link that they didn't realize the size of the file, with the metadata you can really see it maybe clearer and easier, because what's happening is that the software is extracting the complexity so the user can see the information that matters, can see the wood from the trees a bit easier. It just reminds me of a story a few years ago when I was going to a rugby match in Dublin. And I got out of the car with my son, and I got a phone call on my cell, and it was a guy from Canada that we had dealt with who was in the business, and he said he had moved from a telco to this business in Canada, and he said, John, and I said, yeah, Peter, how's it going? So I said, how fast can you get a box to Canada? Because we're having issues on the network here. We're using Wireshark, but there's too much detail and we can't really go back and see what's happening. We can't stop it. So I said, well, you can download a software and put it on the network. And it was actually an issue where somebody had put a large image on their website and somebody had tweeted about it. And the image, everybody was pulling down the image from this URI and killing the performance. And we could see straight away with the metadata. But if you were looking at Wireshark or a tool like that, which is a fantastic tool, to try and see that level of detail, it was trickier. I guess a real expert could probably see pretty quickly. But I guess when you with metadata, last thing I would say, maybe, it's very useful for maybe normal guys that really want to see some names pretty quick, and be it file names or usernames or domain names, and see, is it the problem? Is it user related or not? Yeah. I don't know, does that make sense?
I think let me put my my marketing hat on for a minute. I think that sometimes in the past, often in the past, I have to kind of explain to my own team when I was running my own company, and also to our sponsors, what exactly is marketing and how we could help them with the marketing. And so I think people tend to confuse marketing with advertising, and marketing to me is really finding the perfect impedance match between what you can offer as a solution and what your customer perceive as a problem, right? So I think that what I like to offer is that, and the marketing message is ultimately the most important when you actually have a champion in your customer who's actually who's quite interested in your product, understand what it can do, and what he has to do now is to take that message through his organization to try to get approval. So that person is in fact your champion now, and so that marketing message is ultimately to help your customer to sell your product like that. And so when this is the third time that I'm listening to your product and your pitch, and I think I finally understand it now that the point here is really intelligence, right? And not so much as in artificial intelligence. It's really putting the intelligence back into packet capturing and forensics. And instead of just capturing bulk data, what you're doing is you say, well, let's just look at what are we really trying to capture. And I think Darragh pointed out that we're not really interested in packets as much as we're interested in activities. And so what we're doing is we're really looking from the very beginning. We're trying to put that human intelligence in there to really dissect traffic and capture just the most important information. Now, of course, there's some benefits to that, and Darragh mentioned cost, right? It's a very expensive proposition to store all the data, but you can argue that, hey, the storage is cheap. What's the problem? Well, then, sort of the flip side to that is scalability. That might be cheap now for 1 gigabyte, but it might not be cheap for 10. And it might not be cheap for down the road. So it's not just inexpensive. Is scalability, but ultimately, again, this is back to marketing, where I'm saying, what is the perfect impedance match between what you have to offer as a solution and what the customer perceive as a problem. And if I were your customer, and I just listened to 3 presentations now, so I really understand the product, I really understand why I need it. And now I just have to run up to the 3rd floor and explain it to my vice president. The only message I have to give I have to give to my boss is time to resolution. That ultimately is what metadata means. Is that I don't have. It's not like I have to go back and look at all of the packets and figure out what to do. Right?
Well, I think it's the difference between data and information.
Yes. And I think that's very powerful. That's extremely powerful. I'm really excited.
Yeah. And the other important point, Denny, this is a good point that you mentioned marketing. You brought into it, and the other point, you touched on something very interesting there. When you got to run upstairs to your boss, and when you run upstairs to your boss, and you show him a load of bits and bytes, he's going to say, "Sorry, what am I looking at?" If you run upstairs to your boss and you show him a lot of usernames and file names and say, I can track, for example, and keep it for months, and keep an audit trail of every file that John accessed in case it went missing or in case it went missing later. And you show him usernames and file names and domain names, names that he can understand.
That's right.
Names that he says about what the users are doing on the network, how his key resources are used. You're going to sell. Yeah. He's going to see something that makes sense to him.
That's right, because what he really wants to do, what the entire organization wants to do, is to resolve the problem. They're not really interested in the capability and the feature. Hey Tim, I want to give you an opportunity, and before the show we talked a lot about law enforcement, and that there are some confusions out there, on whether or not metadata is the right thing to do. Why don't you can? I think this is a good opportunity for you to bring that perspective in.
Well, when you talk about lawful intercept, it's not just about law enforcement. It's about auditing compliance, internal security matters, e-discovery, the whole gamut. But there, people tend to look at data in different ways. And in law enforcement or in lawful intercept, which is the common term for all of that, you want to be able to, as quickly as possible, find what we call the articulated suspicion. We want to be able to focus whether it's for lawful intercept or it's for why can't I get my active screensaver or why is my computer freezing, why can't I get messages, all of that stuff. And of course today with the constant everyday hacks going on and malware, spoofing, everything. I mean, Darragh, you've seen it too. I mean, so do you, John. You see it all the time. So I think the biggest thing about metadata, and there is a discussion going on, is metadata sufficient for lawful intercept, in other words, for like CALIA or WISPA, the wireless ISP intercept, and internationally there are a whole bunch of other names. Or is it only good for and what we call an articulated suspicion, which allows us to go get a warrant? And I believe that over the next year or so, we're going to see metadata being much more than just that articulated suspicion. It's going to give us the ability to look at stuff that we've never seen before without capturing terabytes of data. I mean, as Darragh pointed out, my gosh, can you imagine, Darragh, monitoring a 200-person company with 10 gig backbone and trying to find exactly what happened 15 days ago or even 5 days ago?
Don't even need a network that size. I changed my broadband to 16 megabytes a couple of days back. I've everything up and running here. You know, kids and tablets and me doing my work and data, like videos being streamed across into the house. Every day there's hundreds and hundreds of gigabytes of data, and that's just me. It's
and that's viable.
It's the data rates are going up and up and up and up.
Well, that's viable data. When you look at all the other crap, pardon me, all of the data stuff, I call it, that goes on. I mean, look at IPv6. I mean, now with Win 7 and Win 8, IPv6 is on whether you want it on or not, and that can run anywhere from 5 to 12% of your bandwidth for no reason. And it's huge. I mean, that's what I'm agreeing. It's outrageous, and that's the great thing about metadata. It allows us to focus very quickly on stuff. There are limits in metadata as to what we can see, but what it does is, like you were saying with Wireshark, I can filter on stuff, but I've got to find out, first off, I got to find out what I got to filter on, and that can be a monstrous task. Today, very few people really understand TCP/IP, much less IPv6 and all the other.
Absolutely. What we find from network managers is the crucial piece of data that they would need to filter on will be given to them after the event happens.
Absolutely.
So they'll be told,
well, yeah.
Hey,
who accessed this website, who deleted this file. And
guys, I don't. My experience is that if we try to do this if you try to bring this into a 45-minute hour show, a lot of our viewers would look at that and says, well, I'll watch it over the weekend because I don't have that much time right now. So I don't want to make this a very long show. Okay. I want to invite Darragh to as a follow-up, write an article. I think there are two things we can do as a follow-up. One is that I think that we talk about Darragh writing an article, posting on O2 that kind of summarize what he talked about today, which is that why use metadata when doing deep packet analysis.
Writing it down at the moment.
Yeah. So that's one thing I suggest that we can do as a follow-up. The second thing that I would suggest as a follow-up, because it is such an interesting topic, such an important topic, is that we can also have a panel discussion by inviting both of you gentlemen back, as well as some other writers, people who might have a different perspective on that. I think that would be a good thing to do a follow-up. So let's do that. But I want to maybe use the next minute or two, give John a chance to talk about his company. I have this I have this habit that whenever I want to learn about a new topic, whenever I find a topic that is worthy of my time, I tend not to want to just accept the conclusion, right? I want to go back to the origin. I wanted to go back to the man's head and say, hey, where was that aha moment, the time when he thought that this was the right place to go? So why don't we do that? And John, I'll give you a chance to kind of close the show. Tell us about who you are, who your company, but more importantly, tell us, how did you get started with this? Why was this important? Why was this approach important to you back in the days?
That's a good question. I mean, I guess, you know, when we were doing this initially, and we were looking at traffic, and we were looking at more or less from a security point of view, and a network guy who had a Cisco switch said to us, you know, and we were connected to a span port, and I know there's different issues with span port, and I think with span ports and what users are doing, they can give you a good picture. And he said, you know, I want my span port back. And he said, I was using it for getting visibility into what was going on in my network for troubleshooting. And we realized that there's a lot of good information in traffic. Like people, Denny, when they see, for example, now that you can get file names and actions and that level of detail from traffic, they go, I don't believe it. You can get that information by sniffing traffic off the wire. Normal guys do not believe it. So I guess I will finish up by, it is absolutely amazing and fantastic and can be used for so many use cases. What you can get from traffic, what you can get from traffic in Wireshark, or what you can get from metadata. It's all about really, at the time, presenting it at the right level, so that you know you can see the wood from the trees. But if you need to, you can also get the detail and get the drill down to really understand the problem. And trying to do that with software, trying to extract the complexity, present the big picture with traffic, and use tools like Wireshark or metadata, you know, being proactively knowing what's going on in your network internally, not just at the edge, can have really many benefits for all sorts of organizations of all sizes.
Good, thank you, John. And in case some of viewers want to get a taste of your product and what it can do, can they get a free demo?
Yeah, they can go to netfort.com. Our website, there's an online demo system they can play with themselves, or they can download a 30-day trial. They can put it on a virtual appliance or a physical appliance. It's got all the features turned on, and they can play with it, and they can ask for an extension. They can, you know, they can see with their own traffic what it does in their own network. And when you see information in your own house, in your own traffic, it's just a different story. It's really useful.
Thank you,
yeah,
John.
and in fact, if any of the viewers have a problem on their network, it's a great tool to download. You got a 30-day trial, so you know you've got plenty of time there. If you had an issue, slow network, especially if like slow internet or suspicion about stuff, it's a great tool to troubleshoot a problem. You know, the trial, as John said, is fully featured, so we don't try and throttle you that you only can capture one IP. It's a great tool if you've got an issue right now. Download it, get it installed, and you get to see what's happening.
Yeah, may I add one point to that? It's a great device, and it shows you things instantly. I don't like to call it a tool because it's much broader than that. And I really do believe that the discussion about is metadata acceptable for lawful intercept for legal reasons, I think we're going to see that grow over the next year or more.
Okay, well, with that, I'm going to close the show. By the way, I met John for the first time back in the summertime frame when we were attending ShopFest together, and I promised him that, and he became a sponsor right away. We were very grateful to that, and I promised him that we would do at least 3 shows for him. And I thought this was the last. I thought this was it. I can go back to my life. But it looks like this is just the beginning.
Yeah, I'd like to see, hey, Darrell,
Yep.
Darragh, one thing I'd love to see is if you have anybody that's been attacked, DDoS, SQL injection, if you got anything like that, I think that's going to bring up a whole new sector of people. If you can talk about that, people will freak because that's
well,
something
let's really think hard
Sure,
about that and maybe fit that into a panel discussion format. Okay, so with that, I'm going to close the show. It's been 45 minutes. Thank you very much. Thanks, Darragh.
Thanks, everybody.
I really enjoy your presentation. Thanks, John, for coming. I know you're very busy.
No problem. No problem.
Okay, and thank you, Tim. And,
thanks very much, Jay. Thanks, guys. Thanks, Tim.
With that,
thanks,
I bid you goodbye and have a great week and be good. Bye-bye.
Bye-bye, guys.